Welcome and greetings to all from the OMNIX USA team. We are excited and grateful you could join us today for the OMNIX educational webinar series, designed to empower our customers making tooling decisions. Today's topic, Troubleshooting Part 2, will be presented by Jack Downer and myself, Michael Stelbaski. The presentation will take 20 minutes, followed by 15 minutes to address questions. We encourage you to submit your questions at any time during the webinar by using the chat box function. A live Q&A session using the cell number provided in our email will immediately follow the presentation. Today's agenda will cover 3 primary points. First, basic bend theory, highlighting the bending process, the perfect bend, and key factors. Secondly, troubleshooting basics. And third, 6 common issues and solutions. I will now turn the mic over to Jack Downer.
Thank you, Michael. To begin the basic bend theory, let's talk about what happens in the bending process. The inside radius, known as the ISR, compresses, and the outside radius, known as the OSR, stretches. The tube material flows in the path of least resistance. The durable tooling, known as the bend die, clamp die, and pressure die, capture the outside of the tube. When needed, the mandrel, with proper clearance and positioning, keeps the tube material from collapsing inward. When needed, the wiper takes the material in the ISR trying to wrinkle and forces or wipes the material to flow further back in the ISR to keep wrinkles from forming. When it comes to making perfect bends, several factors come into play. Determine that the bender you will be using is properly operating. Make sure the clamping and unclamping of the dies, rotation of the swing arm, and extracting of the mandrel are all occurring in the proper sequence. Make sure the tube you will be using is clean both inside and out. Check your tooling, making sure it is clean, burr-free, and compatible with the tube to be bent. Confirm that the mandrel, if needed, is the required distance past tangent. Confirm that the wiper, if needed, is the required distance behind tangent. The 3 key factors affecting the bending process are drag, support, and positioning. The main components affecting drag are too tight of a mandrel, too much pressure die force, negative rake on the wiper die, not enough lube, weld flash location, and collet or PDA speed too low. The main components affecting support are interlock, dog ears, proper sized mandrel, enough grip so you don't slip, which is the length and the surface type of the grips, correct mandrel and wiper material for the application. The main components affecting positioning are mandrel setup, wiper die setup, proper pressure for clamps and pressure die, tube position if you have a weld seam or flash, clamp and pressure alignment. When an issue comes up that the cause is not clear, you will want to collect some key information first that may bring the cause to the surface. The list provided here is where we recommend to start. It's your tube OD, wall thickness, and CLR you are bending, the tube material you're bending, and check to see if you're using the correct mandrel and wiper combination using the selection chart that we'll talk about here shortly. measurement of the finished OD of the mandrel nose, measurement of the finished OD of your mandrel balls, measurement of the tube ID while clamped in the bender, mandrel position ahead of tangent, wiper position behind tangent. And note if the tube is slipping during bending, and you can use a Sharpie ring in front of the clamps as a process to validate that. If you put the ring in front of the clamps and then bend the tube and you no longer see the ring, then you are slipping, but if you still see the ring, then you know you have no slippage. This chart is a tool that provides the direction for the kind of mandrel and wiper combination needed when higher quality bends are desired. We'll cover this chart in a little detail today. There are three parameters that drive the use of this chart: tube OD, wall thickness, and bend radius. There are two formulas shown: D of bend and wall factor. And in order to get your wall factor, you take the wall thickness and you divide it into the tube OD. And in order to get your D of bend, you take the tube OD and you divide it into your bend radius. As an example, if we have a wall factor that comes out at 27, and we'd recommend that you round it up, and you have a 2D bend, you would come down here, you would see that it shows an M2W, and that represents a mandrel with two balls and a wiper. If you're having some slipping issues, at a 27, you may be able to actually work with just one ball, which will reduce your drag and possibly eliminate that slippage. So that's one form in which you can utilize this chart to help you troubleshoot and possibly be able to eliminate your issue. The other key thing to keep in mind with this chart is as the D of bend gets tighter and your wall factor increases, the need for potentially a different style mandrel is going to show up on the chart. In the gray area, these are all standard pitch mandrels. In the yellow area, the TW stands for thin wall, and you also hear closed pitch, which is the same configuration. And then we also have in this blue area, ultra thin wall, or sometimes referred to as ultra closed pitch. Material compatibility. Typically, the mandrel and wiper recommendations are intended to avoid galling between similar materials. Soft tubes need hard mandrels and wipers, such as bending steel, copper, or aluminum, and they get the best life using tool steel chrome. Hard tubes need softer mandrels and wipers. When you're bending stainless steel, titanium, or Inconel, typically you'll go with the aluminum bronze. This chart here shows two forms of bronze. There is AB18, which is the industry standard, and ABX, which is a harder, more durable option offered by OMNI for about 25% more cost and typically provides 2 times or more life. Clearance is another key component in troubleshooting and part of why you collected the information noted on the earlier slide. Clearance is the space between the ID of the tube and the finished OD of your shank and balls. The amount of clearance determines the amount of opportunity there is for deformation in your finished product, OSR flatness, ISR suck-in, and tube outside of roundness. There are 3 different clearance standards: automotive, aerospace, and shipyard. Aerospace is considered the tightest tolerance with a clearance of 3 thousandths to 7 thousandths. Automotive provides a bit more clearance in the 10 thousandths to 15 thousandths range. And shipyard, which we usually see heavy wall pipe and tube, has clearances typically in the range of 25 thousandths and up. Too much clearance allows for more flatness of the OSR and waves or wrinkles that can develop on the ISR. Too little clearance can create drag, putting more load on your grips with potential slippage, and can also squeeze out your lubrication, creating more drag. The worst case, the variation of your tube material may not allow you to load the tube over your mandrel if your mandrel is not sized properly to the tube. Another key note about material specifications. The range of variation of the dimensions of the tube allowed by the spec can exceed the automotive and aerospace bending clearances we discussed above by 2 to 3-fold. Understanding the sizing of your material or having a mandrel size to your specific material can save you a lot of unexpected issues, scrap, and cost from one lot of material to the next. When you are using material with weld seams, it adds another layer of issue to discuss outside this presentation. This covers the basic bend theory and troubleshooting basics. To present the troubleshooting of common issues, I will turn the mic over to.
Thank you, Jack. As we go through the next slides, please write down your questions in preparation for the Q&A session hosted by OMNIX Technical Support Team Leader, Paul McGowan, immediately following the presentation. Also, let us know by chat if you would like us to email our digital catalog, which highlights the 12 troubleshooting issues found on pages 21 to 23. Now, to pick up where we left off from the previous webinar, Troubleshooting Part 1, Part 2 will address issues 7 through 12. Issue number 7, mandrel ball humps, occurs when there is too much drag on the tube. To alleviate the drag, you should back off the pressure die force and increase the wiper die rake by 1/2 to 1 degree so the tube is able to flow freely forward without hindrance into the bend. A closer pitch mandrel ball assembly can also resolve the issue. It will close the gap between the balls by nesting them closer during the bend, providing more surface to support the OSR of the tube. You could also be experiencing material which is just too soft and is collapsing between the ball gaps. Issue number 8, excessive collapse after tubing is pulled off the mandrel balls. First, check for too much drag on the tube. As shared on the previous slide, you want to reduce the drag by backing off the pressure die force and increase the rake on the wiper die by 1/2 to 1 degree. You may also need to increase mandrel support on the outside of the bend by changing a plug mandrel to a 1-ball, from a 1-ball to a 2-ball, a 2-ball to a 3-ball, and so on. Also important is to make sure the nose of the mandrel shank is positioned slightly ahead of tangent during setup. Issue number 9, heavy wrinkle through the bend area only and linear scratches in the gap area indicating slippage in the clamp. The solution path begins by reducing pressure die force. Then check location and lube of mandrel and wiper die. After checking these initial areas of potential drag on the tube, you will want to increase pressure on the clamp die. If still having slippage, the clamp die grip surface will need to be more aggressive. Optional grip surfaces to consider are serrations, knurls, and carbide spray. You can also use a clamp plug when the tube straight sections are short, if possible. Issue number 10. Deep scratches throughout the bend and in wiper die area. Solutions. Increase the rake or relief in the wiper die, 1 to 2 degrees. Use more and or better lubrication. If needed, seek recommendation from your lube supplier. A galled tube groove in the wiper die can result in deep scratches on the tube surface. If you are using a one-piece wiper, you can have the wiper recut with full machining on the tip and tube groove. Or if using a wiper holder and replaceable wiper inserts, it would be time to change to a new insert. Issue number 11. Tool marks on center of bend. First, check for oversized tube OD. Also, check the clamp and pressure dies for misalignment in the tube groove and readjust as needed. Next, check the bend die for an undersized tube groove. You will want to make sure tools remain aligned during the bending process. Older benders may not have the tooling traveling harmoniously as the bend head rotates to perform the bend. Use of interlock and lip tooling is used to eliminate marking on the top and bottom of the tube center. Issue number 12. Tool marks on the center line of bend in clamp and pressure die area. Solutions. Reduce pressure die force. You could have oversized tube or undersized tube groove. Check for both. Check for alignment issues. If there is too much pressure on the clamp and or pressure die, the tube groove alignment can be compromised, resulting in canting the bend die out of alignment. Again, use interlock and lip tooling to eliminate marking on the top and bottom of the tube center. That concludes our presentation, Troubleshooting Part 2. We will now move to the question and answer session. Submit questions using the Webinar Ninja chat feature or join our conference call. Thank you for joining us today. Talk to you soon.